Time for a second review video. Unit 1B, I'm going to break it down into units here because that video is getting a little bit long. Plus, then you can pick and choose which one you're working on and not have to search through so much. All right. So G-Easy has bought a fixer-upper beach house so he can take it easy. Get it? Get it? I should have done E-A-Z-Y. Next time. All right. He decides he's going to retile the bathroom with some dope marble. Ooh, marble tile. Woo! The blueprint below has a scale of 1/4 inch equals 2 feet. How many square feet of tile should he order? Bathroom is 1.75 inches by 2.75 inches on the blueprint, so we don't have to actually measure it right here. It's just going to tell us what it is. So 1.75 inches and 2.75 inches for my bathroom. Now, we're not going to subtract out all these different fixtures and stuff like that because we don't really have any of those measurements. We're just going to do the whole rectangle, okay? This is obviously also a review of some area. The main thing here would be finding our actual dimensions. That's the Unit 1B topic. All right. Personally, I like to set up a scale factor proportion. So I have 1/4 inch, which would be 0.25. That's a terrible decimal. Let me just try that again. 0.25 is 2 feet. Okay? Inches, feet. I want to know what my actual dimensions are. So how about this? I'm going to erase this and do this in a different color here. You'll see why in a sec. Okay, so if I go back to purple, I know my inches are 1.75 on the blueprint. I want to know what the feet are. So I'm going to do a little bit of math here. 0.25 x equals, and then it would be 2 times 1.75. And I get 3.5. And then dividing by 0.25 is the same as multiplying by 4. Now I say 4. Dividing by 1/4 is the same as multiplying by 4 over 1. But in our calculator, we can divide by 0.25, and I'm going to get x equals 14 feet. So that's one dimension. Now I'm going to switch to green. See what I did there? I wrote the other one in green. All right, so I have the same first part of the proportion, 0.25 over 2. That's inches over feet. And that's going to equal, well, I know it's 2.75 inches. I want the feet. We'll call it y this time. Just a different variable, right? So same kind of math, 0.25 y equals, and then it's 2 times 2.75, which is 5.5. And then divide by 0.25. Y equals, and that's 22 feet. Just double check that we are good. All right, so those are my two dimensions, right? So that's part A. What are the actual dimensions? Boom and boom. So 14 feet by 22 feet. Cool. All right, now the other part asks us here, how many square feet of tile should he order? So let's do that one. I'm gonna use this bottom part here. Well, let's see here. We've got, for our area, we're going to have, sorry about that. Just got a call there. Aubrey's coming home and said, hey, would you like some lunch? And I said, yes, we're getting tacos. All right. Got some al pastor taco dinner from Elson Bro, the best. It's coming my way here in just a few, right? It is 11:56. It's almost lunchtime. Okay. So I want to get my area, right? So my area is going to equal, for a rectangle, is just base times height. So 14 by 22, right? That's what whole point of, finding out my actual dimensions is to get my area so I know how much tile to get. So we've got 308 feet squared. There's my area of the bathroom. And I think that's all it asked. How many square feet of tile should he order? It doesn't say anything about the size of the tiles or anything like that. There we go. Awesome. Next. Whew, that's quite the blueprint. Fetty's blueprint of the main level of the house is pictured below. So Fetty Wap is who we're dealing with here. I think it was a prior problem before. If the 18-foot wall of the living room, let's find that. 18-foot wall, I'm guessing that's the longer one because the other one's 12 and a half, measures 2.5 inches on the blueprint. So this is 18 feet and it's 2.5 inches. Okay. Calculate a scale factor of 1/4 inch equals x feet. Okay. So now I'm going back the other way. And then what type of transformation would you perform when you build off of this blueprint? So the second thing. So if I do 1/4 inch, which we already know is 0.25, is x feet. So we have inches and feet, right? Equals, and I know that the inches are 2.5 and the feet we have here is 18 feet. Okay. So all I'm doing is I'm popping this onto a proportion. That's why, like, the last one, you could have been like, oh, I'll, like, multiply by this or divide by that. Like, you could probably do it in your head. I like the proportion. It's just, like, the same thing every time, and proportions are just super helpful in so many different topics. So I'm going to keep going with that, all right? You don't have to join me, but I suggest you do. So 18 times 0.25 is going to give me 4.5. 4.5 equals 2.5x. If I divide that by 2.5, it's not necessarily going to be that nice. X equals 1.8. So what does that mean? That means 1/4 inch equals 1.8 feet. Now, that would obviously not be a very ideal blueprint scale in real life. But I did want you guys to do a little bit of the math behind it. Usually they'll be like 1/4 inch equals 1 foot, or 1/4 inch equals 10 feet, or whatever. Okay, they'll usually be very nice numbers, but we're just kind of mathing through this one. The next part, what type of transformation would you perform when you build off this blueprint? We're going from small to large. All right, so that is a dilation. Very good. Okay. Oop, kind of covered up some other stuff there. Dilation. All right. Number 3, Fetty. Oh my goodness, Jenny. All right. More deliveries or something going on, right? You know, Jenny's just barking up a storm here. All right. Fetty is replacing his siding when he realizes the gable end truss studs are not consistently spaced every 16 inches. This actually happened to me when I was replacing the siding on my house with the gable end. I was ripping things off. I'm like, these things aren't even spaced right. All right. So I had to redo them. Okay. So this is a big deal when you're nailing the new siding on, right? So you have to nail it too. He wants it to look like the picture below. He has a 7/12 pitch roof and wants studs spaced every 16 inches. What is the length of the stud labeled X? Explain how you determine this answer. So my pitch is 7/12, so 7/12. And so that's rise. Let's do this. Rise over run, right? Now, I want to know the rise, right? X is my rise, but what's my run? That's that length right there. Well, each one is 16 inches on center, right? 16. So we have 16 times 5. Well, what's 16 times 5? 5 times 10 is 50. 6 times 5 is 30, so that'd be 80 inches. All right. Always helpful to do a little quick mental math, right? So that's 80 inches for my run. And that will tell me how high that one is. And I could do that for any one of these studs, right? I could calculate every single one of these heights based off of this. We're just doing one of them for a little practice problem. So I've got 80 times 7 is going to be 560 equals 12x. So I'll take 560 divided by 12, right? 7 times 8 is 56. Pop the 0 on there. And when I divide by 12 here, I'm going to get x equals, and we'll round here. It looks like we got 46.6 repeating, so 6-7 inches. Okay, we'll forego the explanation. We kind of explained it along the way, right? Use our slope. We got one missing dimension. Proportions. I love me some proportions. They're so useful. Okay, T-Pain has decided to triple the dimensions of his living room. The area is currently 1,000 square feet. What will the new area be when he's done with this renovation? So if I have a 1,000 square foot room, let's say it's a rectangle, okay? I triple the dimensions. Well, if I triple them in one direction, they have to be tripled in both directions. And let me go a little bit smaller here and zoom in. Okay, I'm going to ink to shape this time. That's not going to be smaller. Now it's crooked. Okay, there we go. I paused it just in case it kept on messing up, but that was the next one, I swear. Okay, so this is my 1,000. Don't want any more ink to shape. Square feet room. Okay, 1,000 square foot room. He's going to triple the dimensions, right? So we're going actually not just. Ooh, I got an idea. Check this out. Control C, Control V. And I want to change the color of this. Oh, so I'm going 3 in this direction. 1. Right? So that's triple the dimensions in that one, right? And then I want to go triple the dimensions the other way. Okay. So I got to go down like that, right? Now, I got to fill everything else in. All right. So there we are. We went 3 in this direction and 3 in that direction, right? So what will the new area be? Well, I got 9 of these things, right? So I have 9 times 1,000 is going to be 9,000 square feet. Common mistake is just tripling it to 3,000. But then you got the other dimension, and you got those extra ones inside there. So this is gonna be a big old living room. 9,000 square feet. You can play like basketball in there. I feel like. Actually, I don't know what the actual dimensions are of a basketball. I don't know. All right, next one. 2 Chainz. 2 Chainz moved out of his parents' basement and bought a fixer-upper. He decides he's going to paint the garage floor. Fancy garage floor paint, right? Maybe some little sparkles in there. The blueprint below has a scale factor of 1/8 of an inch equals 1 foot. What are the actual dimensions of the garage? Okay, well, we're actually missing a little bit of information here, so I'm going to fill it in. Let's say we've got 1.75 inches on the blueprint and 2.75 inches on the blueprint. Okay? Forgot to add that into the problem. We were going to measure, but we're going to go with that. So we all have the same thing. So how am I going to do that? We actually did one of these already. So I've got 1/8 is 0.125 over 1 foot. So inches, feet. And then I got my blueprint of 1.75, and I don't know what that is. Okay? So go ahead and just cross multiply. So I got 1.75 equals 0.125x. Divide by 0.125. And I'm going to have, so 1.75 divided by 0.125 gives me 14 feet. So that's one of them. And you know what? I'll go ahead and do this as in red. Okay. So now I have 0.125 over 1 is equal to 2.75 over, we'll call it y. Still inches over feet, right? Inches, feet. All right, so you get 0.125. The work's going to look almost the same exact. Y. Divide by 0.125. So 2.75 divided by 1.5. 0.125. Going too fast. Equals 22. Weren't those the dimensions we had for the other one? Weird. And it's a different. Oh, it's, I think they were because it was like 1/4 inch equals 2 feet. So it's kind of the same scale factor. All right, whatever. So we've got 14 by 22 feet. Okay. 14 feet by 22 feet. I think that's good. We've just explained how we arrived at it. All right. Below is a garage front elevation for Snoop Dogg's new chill zone. The actual garage is 18 feet wide, and the blueprint below measures 3.5 inches. Determine a scale factor of 1/8 inch equals x. So we're practicing these again. All right. What type of transformation would you perform when you build off this garage? I think we already know that. Well, let's set this up. So if it is, we're doing 1/8 of an inch, so 0.125 is x. That's inches over feet. And I know that it is 3.5 inches over 18 feet. So I have to cross multiply. So 0.125 times 18 equals 3.5x. 0.125 times 18 is 2.25 equals 3.5x. And then we're going to divide by 3.5. So divide by 3.5. X equals, that's 0.6428. That's terrible. So we'll do 2 decimal places. So I have 1/8 of an inch. So 1/8 inch equals 0.64 feet. That is my scale factor, and it is once again a dilation. That's what we're doing when we build off a blueprint. We're going from small to large, just as we've done in class with our projects. Ooh, yeah. A little more practice. I like this. Getting a few in here, right? Getting a few in case you didn't get it the first time around. So now we have a 512 pitch roof, and you want studs spaced every 16 inches. What is the length of the stud labeled X? Explain how we determine the answer. So my pitch is 512, and I know that it's every 16 inches, right? And this time we're going 1, 2, 3, 4 studs over. So that'd be 64 inches, right? 16 times 4. All right. If you're wondering how I got there. So this is my rise. This is my run. I don't know my rise. That's my X, but my run is 64. And I think we're ready to cross multiply here. So we got 5 times 64. We got 320. equals 12x. We'll divide that by 12. And I end up with x equals 26.67 inches when we round. Cool. Using the diagram to the right, describe the transformations from apartment A to B in that floor plan. Well, we are reflecting over that red line right there. So that's going to be a horizontal reflection. Or you can say reflect over the y-axis. Since we're not really like on a graph here, I'm just going to say horizontal reflection. But reflect over the y-axis would be on a graph. All right, next one. From B to C. From B to C is interesting. It's actually, so it's not a reflection. It's actually a 90-degree clockwise rotation. All right. Whoosh. Cool. Next one. How about we got describe the transformation from B to D. Okay, so from B to D. Well, if we went from B to C, right, that was a 90-degree rotation, and then it looks like a reflection after that. So this is a couple things. So 90-degree. Why did I write degree? 90-degree clockwise rotation. And then we have, it looks like a reflection over that y-axis or a horizontal reflection. Cool. All right. I like it. That's a wonderful thing for transformations there. Let's keep going. All right. Convert. I love some conversions. Okay. So convert the following to, let's see here, 144 inches to feet. So we go 114, not 144, 114 inches to feet. I got to divide by 12. This is linear. So it's just dividing by 12. All right. We're not dealing with area or anything like that. So I get 9.5 feet. Terrible 9. There we go. All right. 32 square feet to square inches. So 32 square feet to square inches. It's going to be a bigger number. I need to multiply by 12 squared because it's area. So 32 times 12 squared, or 144, gives me 4,608 inches squared. Now we're going cubic feet to cubic yards. So 200 cubic feet to cubic yards. That's going to be a smaller number, right? Because yards take up more. And there are 3 feet in a yard, but we're dealing with volume, so cubic units. So I'd have 200 divided by 3 cubed, or 27 is what that number is. And I'm going to get 7.407, so 7.4 yards cubed. All right. There's some good conversions. Nice little refresher there. All right. Find the missing values. Assume the figures are similar. So we got 2 triangles here that we're dealing with. Similar figures. I can use proportions all day with this stuff. So for this one, I've got, looks like 8 and 12 are corresponding. 8 over 12 is equal to x over 20. And I can go ahead and cross multiply and solve. So I'm going to have 8 times 20 is 160 equals 12x. Divide by 12, so 160 divided by 12. That gives me 13.3 inches. Now, if you're wondering, like, hey, could I have simplified this 8 over 12 before I did that? Yeah, you could have. You could have brought that down to, what, 2/3, and then have smaller numbers to work with. Either way is cool. All right, for this one here, looks like we got ourselves a little 3x3, either square or rhombus, right? But the sides are the same, so, well, if that's 3x3, then if this one's 12, then that's 12 right there. I don't think we really need to do a proportion with that one. Done. All right, this one, though, definitely one that trips people up. So I'm dealing with 2 triangles, but they're like one's inside the other. So I have the 6 over 7 for the one. Now my height of the other one is x, and the entire side of this one is 15. I got to use the full 15. I can't use the 7 or a portion of that. Sometimes we only give you this as being like 8, and you have to actually add those 2 together to get 15 for the full side. That's definitely trickier. So now I can just cross multiply and solve. I have 6 times 15, which would be what, 90? Yep. So we get 90 equals 7x. And if I divide that by 7, I should get some kind of a decimal. X equals 12.857, so 12.9 feet. Lovely. All right. Now we got ourselves a nice little shadow type problem here. Let's see here. All right, just had myself a delicious taco break. We just got home. We had tacos, and it was wonderful. So let's go on to problem number 13 here. The sun casts a 15-foot shadow of a pole, right? Maybe like a flagpole or something like that. So I'm going to draw that up. So let's say we have a 15-foot shadow, and then a fire hydrant, which is 3 feet tall. I'll make the fire hydrant red because that's fun. Makes a 9-foot shadow. Okay. We want to know how tall is that flagpole. Basically what we have going on here are two similar triangles. Okay? So we can set up a proportion for this. So I'd have my height of x, I go with the green, and the length of the shadow is 15 equals. Then I've got my height of the fire hydrant, and then we have the length of that shadow, which is 9. This is quite the shadow here. It must be later at night, you know, to get that long shadow. Maybe they're in like Alaska or something. I don't know, man. So I've got 9x equals 45. Divide by 9, and I get x equals, and that's going to be, what, 5? Cool. So whatever that is, probably not a flagpole if it's only 5 feet tall, but 5 feet for that. Awesome, wonderful, and fantastic. Number 14, just some basic proportions here already set up for us. So I'm going to cross multiply. I've got x times 9, which is 9x. And then I've got 3 times 7 is 21. Divide by 9. And since these are just like your straight ahead math problems, I'm going to simplify the fraction. Those are both divisible by 3. So I'm going to get 7 over 3 as my final answer. We'll leave it as a fraction. Next one, got to be careful with this because I have 11 times x plus 1. So I'm going to write out 11 times the quantity x plus 1. So we'll put that in parentheses equals 5 times 6 is 30. And then I got to remember to distribute. So I've got 11x equals 22. Or so, not, what am I doing? 11x plus 1, 11. Okay, I'm falling apart here. I'm falling apart. 11x plus 11 equals 30. I'm going to subtract 11. And I get 19. And now I can divide by 11. And I can't simplify 19 over 11, so we'll just leave it as x equals 19 over 11. Sorry about the mistakes there. All right. A couple more in this particular chapter. Is that the, yeah, some transformations after that. All right. Looking at a blueprint, you measure two sides of a rectangular room. One of them is 7 1/4, and the other is 6 3/8. The scale is 1/8 of an inch equals 1 foot. What are the real life lengths of the walls, and what is the real life area of the room? So 2 parts here. I'm going to draw up a rectangle. One of them is 7 1/4, so 7.25 inches. The other is 6 3/8, so that's 6.325 if you know your eighths like I do. Not everybody does. It takes a lot of repetition with those and seeing them all the time. Okay, so I want to know what are the real life lengths of the walls. And I've already done this before, but let's do this guy in a different color. We'll go with blue for that. So the first one will be our 7 point. That's not what I want. There we go. Boom. Okay. Now I'm ready. 7.25 inches. So I have 7. What's my scale factor? We'll go with that first. 0.125 for 1/8 of an inch equals 1 foot, inches and feet. And then I have my 7.25. That's my blueprint dimension. And I want to know what the real life dimensions are. So we'll call that x. So I'm going to cross multiply, solve. I get 0.125 equal, or x equals 1 times 7.25 is just 7.25. We'll divide by 0.125 and get our first dimension. If you're like, haven't we done this before? Yeah, we've done a few of these now. Definitely some good practice. Going to be on that final. So x equals 58 feet. So that's my first dimension. So 58 feet by, now I can do the same thing, but with my other one. So I've got 0.125, so inches and feet. We got 0.125 for my scale factor over 1 foot is equal to 6.325 for the 6 3/8 over, we'll call it y. I'm going to cross multiply and solve. So I get 0.125 y equals 6.325, and divide that by the 0.125, and I get 50.6 feet. Alrighty, so that's my other one, by 50.6 feet. So what are the real life lengths of the walls? There we go. Next one is, what's the real life area of the room? I'm going to get this guy out of the way. Make it a little smaller. There we go. Well, if I got my two dimensions, I can just multiply those two together, right? So 58 times 50.6. That's going to be, already got the 50.6. We got 2,934.8 feet squared. Don't forget the squared. That is my real life area of the room. That's all it asks for. Ready to move on. Now we're into some transformations with graphs, a little more mathy math than application. So graph the image of the figure using the transformations given. I want to rotate 180 degrees about the origin. So if I'm currently in that third quadrant, I'm going to rotate, and if it's not specified, it's clockwise, but 180 degrees really doesn't matter. I'm going to rotate this thing all the way over to here. Okay? So let's do that. Well, this point here is relatively straightforward to rotate. It's just going to boom. Okay? So that one's going to be right here. And that's I prime. J, well, to get there, what I'm going to do is I'm going to make some dashes. I'm going up 3, and then I'm going over 5. Okay? And if I think about this thing as like an L that rotates, it will rotate around 180 degrees to this spot right here. And that's going to be J prime. So if you think about how that's actually moving, I wonder if I can do it with a solid line. Let's see here. I don't know. Hold on. Rotate 90, which would put it right here. And then let me do that again. Rotate again. 90 again. And remember, it's going about the origin, so that little spot right there needs to be the origin. Boom, there it is. J. That was pretty cool, using technology and things. All right, let me erase some of this stuff to get that out of the way. Okay, and then we've got H. All right, I decided to do a little location change to the garage there. So, all right, I got my little heater above me. You know, it's nice and toasty. Okay, so next one, we got H. So for this one, I am going up 1, 2, 3, and over 3. And if I were to do that fancy with that point being at the center, right, because that's the origin, if I were to rotate this thing, not order, rotate 90, that would be right here. And then I'm going to rotate it 90 again. And that goes right. It's got to be on that point, right? A little bit off there. There we go. And my point would be right. Oops. There. Boom. All right. So that's going to be H prime. Let me get rid of that. So that's H prime. And get rid of my origin. Okay. So let's see if this looks right. You know, it's always good to be like, hey, man, does that even look normal? Does it look distorted? Like, what's going on? That definitely looks like it's been rotated that 180 degrees. I like it. That's perfect. That's fantastic. Let's do a different one. All right, we're going to rotate this counterclockwise. Ooh, counterclockwise about the origin. 90 degrees. All right, so this is going to be like, whoop. Okay, so some of these points are going to be, it's a weird arrow. Some of these points are going to be in different quadrants. So let's go for it and get to work. So I'm going to move W first. So this is my point W right here, right? From origin, let me do this. The point, boom. Okay, so I want to rotate that 90 degrees counterclockwise. So again, I can use fancy technology here. I'll do it on the first one, and I won't do it on the other ones. But rotate it. I want to go to the left or counterclockwise 90 degrees. Reposition that guy back at the origin. Boom. I can see exactly where my point is, right? It is right here, and that is W prime. All right. Now, X, that's going to rotate 90 degrees. That's just going to be right up top here. X prime. And then V, I do need to use my little L thingy here, right? So I'm going to rotate that 90 degrees, which would put it, if I'm going to the right 2 and down 3 to get to it, I'd go up and to the right 3. That would be my rotation, right? And then I would be right here with V prime. Okay? I always think of these as like little L's that I'm like rotating. Okay? I'm rotating that up and I'm pivoting on that point right there. So to go from V to that origin, I went up 3 and to the left 2. Now I got to swap that around. I'm going to go to the left 3 and down 2. Okay? All right. Awesome. Fantastic. Let's connect the dots. See if it looks about right. I like it. That looks like a rotation. 90 degrees counterclockwise. We're good. All righty. 6 units to the left and 3 units down. Okay. Let's see here. All I'm doing is shifting this thing. So 6 to the left. That would put me at this spot. And then I'm starting with X. I'm going to go 3 units down. Boom. Here's X prime. For W, 6 units to the left. So that's there. And then 3 units down. Puts me right here. W prime. And then 6 units to the left here and 3 units down would be right here for X prime. Or is that V? That's a V right there. Might have made that mistake on the other one. And then for Y, go into 6 to the left and 3 units down. There is Y prime. And if I connect all these dots, does it look like the same shape, but it's just been moved? That certainly does. I like it. Now I'm curious. Did I make a mistake over here? This is like a... Oh, I guess that was an X. And it was an X-axis, I think. Okay, cool. All righty. There we go. Lovely. Next one. 5 units to the right and 2 units down. I'll start with K, because it's first alphabetically. I had to sing the alphabet in my head real quick. 5 units to the right, 2 units down, puts me K prime right here. L, 5 units to the right. That'd be right here. And then 2 units down would be right here. There's L prime. J, 5 units to the right, 2 down would be right here. That looks like the same diagram, except for that last line I didn't connect. Could you say that? No, Siri, no. There we go. All righty. Lovely. Sure well, no, I didn't say anything, Siri. It keeps on asking me. I mean, I'm doing math here, right? Lovely. Reflect across the x-axis, or the x equals 2, not the x-axis. X equals 2. So let's pop that line down, shall we? I'm going to use my ruler so it's nice and straight. So x equals 2 is actually a vertical line, not a horizontal line. And that's going to be right here. So I am reflecting across that line. Okay? So if I were to place these points, R would be right over here, so that's R prime. S would reflect over to here, so that's S prime. And Q would be 3 away, so Q would be right here, Q prime. It's an O. There we go. Connect all my dots. That was very squiggly. That's better. And there it is, reflected across X equals 2. Over here, across the Y axis, so we're just using this Y axis right there, right? Okay. So S actually stays the same. So this is going to be S prime regardless. Q is going to go 3 over here. Since it's 3 away on the right side, it's going to be 3 away when you reflect it. And then R is going to be 2. All right. And if I can connect these dots, there we go. We got ourselves a reflected triangle across the Y axis. Woo! All right. Oh, that's it for that one. So I hope you guys enjoyed it. We'll do the second part here, the third part actually here in just a sec. Awesome sauce.